It's time for data analytics. Okay, if you are half as excited as I am, this is going to be great. We're going to start with the topic of data frames. What, you may ask, is a data frame? Well, a data frame is a two-dimensional pandas object that consists of rows and columns. So, I want to show you what a data frame is by looking at how they are in fact loaded using Python. Okay, the first thing we need is a library to handle big data. That is going to be pandas. We're going to use pandas all this week and all next week to handle big data. So you import pandas as PD, which is standard, and which means whenever you call PD, you're invoking the pandas library. Next, df equals, okay, so we're assigning a new variable df, which is short for data frame. PD dot, that means we're calling the pandas library read underscore CSV. What this means is our data is stored as a CSV file. At Berkeley Coding Academy, we pretty much exclusively use CSV files. They've become the norm in data science. They're just a really nice way to both store and retrieve data files. So inside of that parentheses, inside of the quotations, would be typically a CSV file. It could be a local file on your computer or a URL that is stored in the appropriate way. We will most often use URLs for ease of loading. And then df.head. That is a data frame method which shows the top of the data. There you have it. That is what a data frame looks like in pandas. I just think it's very elegant and clean. And I will let you know, this is the famous iris dataset from the 1930s, arguably the most famous in all of machine learning and data analytics, created by statistician Robert Fisher. As you can see, there are only 4 columns, the sepal length and width and the petal length and width, that are measured and commonly used to predict the 5th and final class column, which are 3 different kinds of iris flowers. Okay, now let's look at some data frame methods. Well, a data frame is a commonly used Python type in the pandas library. Like all types, data frames have their own methods. Data frames are almost always stored as df. Methods are accessed using dot notation, like you just saw, df.head. And this shows the first 5 rows of the data frame df. Here is another data frame. This one, as you can see, involves weather. It has temperature, clouds, pressure, rain, time, humidity, wind, and location. Looks like it's in Boston. And I will say this, when I look at a data frame, and we're going to help you with this today because you're going to choose your data sets today, you want to try to think about it in terms of machine learning, which means, hey, is there one column that would be interesting to predict from the others? And this one, I think it would be rain. Can you use clouds, pressure, humidity, and wind to predict the amount of rainfall? I don't know. Machine learning can't answer that question for us. Okay, now let's look at some additional df data frame methods. Okay, there's df.info. Let's look at what this does. Okay, a lot of stuff here going on, right? So let's just look at some of it, some of the key pieces. Okay, we can start with the entries, which are the number of rows. You can see that there's 6,276 with indices 0 to 6,275. That's considered standard, not very big today. Okay, we also have dtype. This is short for data type, and it gives us the column types. You see floats and ints, and then object. And note that object is usually a string. We also have the name of the columns, right? We looked at these from the data set itself when we looked at df.head. And there's some other stuff as well in there that you can check out. Although very importantly, the non-null count. This indicates null values. Null values are no entry. They will be a big topic later. And note the rain column where it says 894 non-null. That means clearly that there are null values, meaning missing data in the rain column. So likely instead of somebody putting 0 for no rain, they wrote NA for not applicable. We'll talk more about that on another day. Okay, let's look at some other methods. df.describe, big one. Oh my gosh, look at this. My AP Stats students will weep. Yes, it is this easy in Python. You can get the mean, standard deviation, and the quartiles all at once. Now, my expectation is not that you all know statistics. My expectation is that I can present to you what the basics of these are, and that along the way during this week, you'll learn enough to be able to use this information to help you make sense of the data that you'll be looking at. Okay, so let's start with the mean. The mean is the average. So imagine we have a list, my list, 4, 4, and 10. The mean of my list is 4 plus 4 plus 10 divided by 3 because there are 3 entries. And that results in an output of 6. The median is the number in the middle. So if we have the same list with elements 4, 4, and 10, then we look at the median of my list, we get 4. By the way, in Python, mean is a global function, I think, or it's in a list function, and median is not. Okay, it is in pandas. Just mentioning that the median has to be hard-coded sometimes in Python. Pandas has a lot of shortcuts for everything useful with data analytics. You guys are going to like it. Okay, now let's look at the mean versus the median. This, I think, is the fundamental piece in descriptive statistics. It's understanding the difference between the two. So both are measures of central tendency. The mean is often the default average, and the median is not swayed by outliers. Outliers are extreme values that skew the data. So imagine that we have this list of incomes. 75,000, 80,000, 85,000, and 17 million. Okay, the last one is an outlier because it's way higher than the other incomes. Okay, let's keep going with that example. So 3 incomes, 75, 80, and 85,000. The median and the mean are both 80,000 here. When the mean equals the median, the data is perfectly symmetric. That almost never happens with big data, but when they're close, you have symmetric data. Otherwise, it's kind of skewed. Now, if we go back and add that value of 17 million, see what happens. Well, the median is 82,500. Note that since there's no middle value, to get the median, you actually take the mean of the two values that are closest to the middle. So 82,500 basically is the average of 80,000 and 85,000, or if you like, it's the mean of 80,000 and 85,000. The word average starts to lose its meaning when you get into different measures of central tendency. Okay. The mode is another one, by the way, which is the most common one. So this is indicative of the average income, right? People make on average about 82,500. But the mean is 4,310,000. Okay? Clearly, this is not indicative of the average income. Whenever you are looking at income, you should be looking at median income. Okay, note that. What else can we do with mean versus median? Well, the mean comes with the standard deviation, abbreviated STD. The standard deviation is the expected variation from the average. So if the mean is 6 and the standard deviation is 1, values from 5 to 7 and 4 to 8 are expected. The median, by contrast, comes with quartiles. So the median is the 50% quartile, meaning the value in the middle. The 25% quartile is the value at the 1/4 mark of the ordered data. I mentioned ordered because you don't know what it is until you put it in order from least to greatest. The mean, you can just add them all up. You don't have to have it ordered. Another way you can look at the 25% quartile is that it's the median of the first half of the data. And the 75th percent quartile is the value at the 3/4 mark of the ordered data. So in effect, you find the median, and that splits the data in half, and then you find two more medians. And those are the 25% and the 75% quartile. Happy coding.